Hey folks, welcome back. This is basically the second video in our series where we are deploying the campus fabric, right, in our small EF topology, right. In the previous video, we discussed how discussed the whole topology in general, and we talked about what is our game plan here, and then we went about deploying the underlay, right, and we checked that there was a very good underlay which is ISS, which is running between all the three edge devices and the border and the control plane node here, right. So all the 4 devices were configured for ISIS and we validated as well. Now in this video we will proceed with our discussion. So let's quickly go back to the config guide, right. So if you have been following till now, right, or if you have already read through the config guide, you will basically see that we have what we have done. We have done this part, which is setting up the management and the underlay mechanism. The next is we are going to do the overlay part, right. And the overlay part is very important, and that's kind of like the meat of the whole discussion, right. So this is literally, we are basically going to be following every step from here, right. So we'll be configuring the edge device. You see the edge device can be configured. You need to have your basic Lisp running on it, right. So this is the control plane, because in the overlay, in the SD access solution, in the overlay or in the campus fabric, right, the overlay is basically divided into 2 things, right. So the control plane is your Lisp and the data plane is your VXLAN, right, and that's basically what we are going to be doing here. Don't worry, I'll explain all the stuff which I'll be putting on the device. I just wanted to quickly show you where you can find the configurations, what we are going to do today or in this video, because if you have any doubts, or if you want to validate something, you can anytime come back to this section of the config guide and you can check out the various stuff, right. So that being said, let's jump back into our topology, right. So like you see, the second step here is basically deploying the overlay. So the first step, what are we going to do? The first thing, right. Now, like I said in the previous video, this is a very simple example of a company, right. We have two different in this organization, we have 2 important functions, which is the sales department and obviously the IT folks, right. So technically you want to have some kind of isolation between these 2 kind of traffic, right. So what is the one way of doing, and there are different ways, yes. One way of doing it at layer 3, right, layer 3 isolation, the first thing which you should think of is VRF, right. So in SD access or in campus fabric, you know what, I'm gonna just say campus fabric from now on, right. It's basically same as saying SD access, so I'm gonna say campus fabric. So in campus fabric, the isolation, the layer 3 isolation, or in other terms, in a fancy way of saying that is macro-segmentation, right. The macro-segmentation is provided by your virtual routing for VRFs basically, right. And again, VRFs are generally called the short form of VRFs, right. In campus fabric they call it as virtual networks, VNs, right. So in our let's go back to my whiteboard probably, right, and maybe let me open a new sheet here just to table down whatever we are going to be doing today, right. So VNs, right, we are going to be deploying the VNs, right. And what are the 2 VNs? Like I said, we have 2 functionalities. One is your sales and the other one is your IT, right. So these are the 2 functionalities or 2 sub organizations in our company. So we want to create, like, we want to segregate their traffic and isolate it completely, right. So these will be the 2 VNs, and the subnet here will be 172.16.10.0/24, whereas this guy is 172.16.20.0/24, right. So that will be the subnet. What is the meaning of the subnet? Now again, in DNAC, right, if you're provisioning your network, you would basically select host pools, right. So this is nothing but that. What I mean by the subnet is, when the clients, right, when the sales clients come and connect to your building, right, when they connect to the switch, they are basically going to be getting IP address from this pool. When the IT folks come and connect to your switches, they are basically going to be authenticated, and it might be a .1x or MAB or whatever, right. And finally they'll be put in a particular VLAN which will give them the subnet, the IP address from this particular pool. So these are the 2 pools which we'll be using. Now the other important thing also which I would like to mention here is infra VN, right. So in campus fabric, generally what people do is, this is VN, or what I said VRF, right. Yeah. So when you talk about VRF, this is a separate routing table, this is a separate routing table, right? The sales is a separate routing table, IT is a separate routing table. Now in case of my in case of Campus Fabric, what they normally do is, in addition to this, right, there is also what we call as a global routing table, right, the GRT, right, that is always there. Irrespective of you create VRFs or not, you are going to have your global routing table. So in my global routing table, I'm going to have one subnet, right, which is generally for all your infra, devices. It could be like your APs, right, access points, right? So and all of that, right? So this is basically, in this, what we are going to have is, we are going to have what we call as the infra VN, VLAN, whatever, right? And the subnet which will be used here is 192.168.10.0/24, right? So this is what we have, literally. These are the three important things. We have the sales VN, we have the IT VN, and then in the global routing table, we have a pool of IP addresses for access points, right? Generally access points, or you have some kind of sensors, right? And those devices, they can be connected directly to the underlay, right? Because global routing table is the underlay, right? So all those access points and stuff, they basically come and connect to this particular subnet. So that is our design, right? That is what we are heading towards. So if you see my, if you go back and see our steps, right, what we have documented, if you go back here, yeah. So if you see here, we are telling that we are going to be doing VNs, the sales VN, the IT VN, and the infra VN, right? So the infra VN is kind of a misnomer, I guess. Probably don't think infra VN is another VN in itself. It's just like, it's a VLAN which is provisioned out of the underlay, right? And if you look at my diagram also here, you can see that the red one, this is your sales, right? Pen is not writing. Give me a second. It's weird. Okay. Yeah. It's slow. Okay. So this is sales, and the green. Wait. Okay. My bad. So the red one is your. Sorry. The red one is your IT. Right. The red one is your IT. And the second one, the green one, is basically your the sales VN which we were talking about, right? Cool. And the other one important thing is the APs over here. See, I have APs on all the three switches, right? So these are the APs which will be part of this infra VN 192.168.10.0, right? So hope that is clear. So we have technically we have like three segregations or three separate subnets which we are going to design in our network. Yeah, this is just an example. I mean, you can scale this to any number of VNs, right? Now the good thing about SD Access is it kind of automates all of this for you, so you will not understand the burden and the trouble to configure this. But since we are configuring it manually, so you get to see all the fun part, right? So let's start with that, right? So we have to configure the VRFs. Now before that, the other important gotcha here, which I want to kind of, something very important which I want to call out here is, going back to my earlier discussion in the previous video, right? Like I said, it's very difficult to simulate or emulate L3 switch, iOS XE L3 switch in any kind of virtual platforms, right? So I've been using a combination of a L3 router, which is a CSR100v, and the switch, IOL switch. Now this brings some challenges. Like, let me explain that quickly, because if you are stuck with something like this as well, it would be useful, right? Give me a second, let me fix my pen. All right, so the problem which I saw here is that I've got my this is my CSR, right? And I have my IOL switch here, right? This is my IOL, right? Now I have my clients connecting up here. The reason why I even added this switch is because the CSR device doesn't have L2 functionality. So the switch port command is not supported on this CSR. So I had to add one more IOL device and connect it this way, right? So now I can do switch port here, right? And I can do VLAN commands and all of that. So this is giving me the L2 functionality, right? This guy is giving me the L2 and this guy is giving me the L3 functionality. Together, when you think of it, it's like a L3 switch, right? Okay, so now the problem here is, what would be the simplest way to achieve this from a networking perspective, right? The simplest way would be to kind of create VLANs, right? So in my case, if you see, I have my remember, I have my sales, I have my IT, and I also have my infra VN, which is nothing but the AP, right? This is nothing but the AP. So the ideal way is to create VLANs, right? So I could create like VLAN 10, VLAN 20, and VLAN 30, 3 different VLANs, and I can trunk it. So I could trunk the port here, right? So that all the 3 VLANs go on this, and here on the CSR100v, I could create sub interfaces, right? I could create sub interfaces to kind of capture the traffic coming in each of the trunks, and then once they come inside the sub interfaces, I can then use it accordingly, right? Basically, the traffic coming in one of the sub interface would be nothing but infra, the other one will be sales, and the other one will be IT, and I can use it and configure whatever I want to do upstream. But the problem is configuring sub interfaces doesn't really work nicely with CSR. So I tried it a couple of times, it did not work. So that's when I kind of went on a bit of a googling, right? Kind of let me show you. I came across an interesting blog or on the Cisco community forum, right? Someone had posted the same question, that they were not able to create the sub interface as well. So that's when I came across this good comment, a very useful comment, where someone had given a very small hacky way of doing it in a slightly different way, right? So because it's a CSR1000 is a router, right? It really doesn't support VLANs and sub interfaces and so on. So a simplest way of that to accomplish is to use bridge domains, right? To use service instance and to use bridge domain. So our logic still remains the same, right? Here everything, whatever we discussed here, this part is same and all the stuff below is same. Only instead of sub interfaces, right, what we will do is we will create what we call as bridge domains, BDI, right? Interface BDI. So we will create 3 bridge domains. We'll create bridge domain 30, we'll create 10, 20 and 30. So we'll have 3 bridge domains, right? And all the traffic coming from here, from the trunk, right, we are going to, in this bridge domain 10, we'll be getting the traffic coming from VLAN 10, right? And this one we'll be getting from 30 and we'll be getting from 20. That way, we are kind of like simulating a sub interface, right? It's not exactly a sub interface, but instead of using sub interface, we'll be using bridge domain throughout, right? So that's the whole reason why we are using bridge domain. In a traditional network, if you're doing it in an actual physical box, right, in a Cat 9K device, you really don't have to do a bridge domain. Instead of doing a bridge domain, what you can do is you can create sub interfaces. I mean, technically you would not even need the sub interfaces, right? Because your 9300 Cat 9K box would act as a L2 L3, so you will not even have this second switch here, right? You basically, the whole thing can be taken care by one single 9300, right? But like I said, whatever I'm trying to do here is trying to create something which people can use, right, to kind of learn the whole solution, right? So this is just a patchy way of doing it, but yeah, it works, right? So just to summarize, the switches which are at the bottom, right, which are the switches, let me show you these switches, which 1, 2, 3, we are gonna create all our L2 stuff, which is the VLANs and all of that, and upstream we are basically going to create the trunk. And on the CSR1000Vs, what we are going to do is we are going to create bridge domains, service instance, bridge domains. That way we can kind of do, we can simulate the sub interfaces or those layer 3 interfaces, which we can then use for, we will do other cool stuff after that, right? So let's quickly get this done with. So we'll go to switch 1, switch 2, switch 3, and let's finish the work on those guys, right? So let's go to switch 1. It's brand new, I guess. I don't think there's anything on this. Yeah, there's nothing on this. So let's quickly go and do that. So where is my switch 1? Yeah, let me clear the screen a bit. All right, so there you go. So host name is done. Let's put in the 3 interfaces, right? So these 3 interfaces are the interfaces on which I'm getting my traffic, right? So interface Ethernet 0/1 is the IT, right? Again, okay, this is the other important thing. Technically in a network you would have authentication in place, right? You would basically, the client, you don't put the client in a VLAN beforehand. You authenticate the client, right? Let's say IT admin is connecting to the network, you authenticate using ICE, right, either .1x or map, and then you assign the VLAN dynamically. But in my case, we are not doing any authentication in my lab, right, because that would kind of make the lab even more intensive, putting in ICE and all of that. Probably I'm not, my server is going to burn off. So I'm not going to do any authentication. I'm going to manually put the individual interfaces in the corresponding VLANs, right? But technically, normally this is the place where you would put your .1x and map, right? So coming back on our switch, we're gonna put the Ethernet 0/1 on VLAN 10, the next one on VLAN 20 and 30. So there you go. So that's done. And once that is done, let's also trunk the interface, upstream interface. Which interface? The one which is going up, right? Ethernet 0/0. So let's trunk that. Sorry. Yeah, there you go. So we are trunking that. Okay, so that looks good. Let's see if show IP interface brief. Okay, looks like the interfaces are coming up. So that's good. So we are done with the switch one. And literally the same configuration would go on the rest of the two guys as well. At least on the second one it's the same. I have kept the ports, symmetrical so that it's easier for us to configure. Like Ethernet 0/1 is connected to IT over here. Here also it is connected to IT and sales and whatnot, right? Ethernet 0/, yeah, that's the same. So let's quickly do that, which means I will have to go to my switch 2. Let's do enable conf t, and let's quickly put in the host name here as well. Switch 2, right? And let's do the configuration on the interfaces, which we just now did. Very similar, same stuff. There you go, right? Show IP interface brief, right? It should come up in a minute. Let me save this as well so that we don't lose this. And the last one is the switch 3. On switch 3, I think I don't have 3 clients. I just have the client on 0/1, which is kind of like the roaming client. And for now, I'm going to put the roaming client in the IT's VLAN itself, right? That is VLAN 10, right? I'm going to put the roaming. I have kept it as roaming, because I want to show you mobility, right? So I'm going to put the roaming guy. In fact, just to avoid the confusion, let me just duplicate this one and let's just put it here. Okay, sorry, not that. My bad. Okay, let's grab that guy. Okay, that's good. So the Ethernet 0/1 is going to be in my VLAN 10, and the Ethernet 0/3, which is the AP VLAN, which is going to be Ethernet VLAN 30, right? So I don't have anything in the sales. I don't have any sales clients on this. Cool. So let's do that. And so the host name is going to be switch 3, I guess. All right. And what are the other two guys? So we've got, so let's do that. Actually, I can do the exact same thing. It's fine, though I don't have the sales client. I can still put the port. It wouldn't hurt. That's fine. And let's do the trunk as well, which is good. So let me save this for a minute and we are good, right? So we are done with all this L2 stuff, right? It was pretty simple. What we did was we just went to each of the switches and we put them in the corresponding VLANs. The VLAN 10 was what we configured for what? For the IT users, right? For the sales users, we went and configured VLAN 20, and for the AP VLAN, we configured VLAN 30, right? Cool. So technically, I mean, all the VLANs on all the 3 devices need not be same. I mean, I have kept it same just for simplicity, but that's the good thing about your having L3 access, right? You really don't have to be same. I can use a different VLAN on switch 1, I can use a different VLAN on switch 2, and I can correspondingly do my configurations and it would still work, right? Anyway, so we have done the L2 part. So now comes the L3 part, which is the CSR100Vs, which is on the top. So the first thing, like I said, we have 3 important virtual networks. One is the sales, IT, and the third one is the infra VN, right? So at layer 3, what is the construct? VRF. So we have to start with configuring the VRFs, right? So let's go to that section. Yeah. So let's go back to my, let's start with, where do we start? Let's start with edge 1 probably, right? Let's start with edge 1 and let's create those VRFs. So let's go back to edge 1. All right. So on this guy, let me clear the screen a bit. Okay. So on edge 1, let's create those VRFs. So we are going to call this guy as VRF definition, probably sales, right? And we will have to put in the enable the address family. Let's enable the address family. Good. And the second guy is the VRF IT, right? That's the second construct, or the second virtual network. So there you go, that is done. And the third one, which is the infra VN, we don't have to create a VRF for that because that guy is going to reside in the global routing table itself, right? Cool. So let me just do this quickly on all the 3 devices. So let me do show run section VRF, right? Because it's the same VRF on all the 3 guys. So I can quickly do this on the edge 2. Let me clear the screen a bit. Right, so there you go, that goes on edge 2, and the third switch also is going to have the same thing, right? There you go. So we've got the 2 VRFs done. Now comes the whole thing which we discussed here, right? Remember the bridge domain discussion which we had? We have done everything. We have done the L2 section, we have done the trunking of the ports and all of that, but on the top, right, we have not done that. So we have done the trunking from the switch side, but on the CSR100v, I said we can't use sub interfaces, so we are going to use bridge domain, right? So let's look at that. If you look at the ports here, all the ports on, it's all gig 2, right? We are using gig 2. So let's configure the gig 2. How do we do that? Let me explain one of it in a in a clear way so that we can quickly go with the second one, right? So go to interface gig 2, right? And we'll say no IP address, right? And we'll say service instance. So we have to create what we call as a service instance, right? Think of service instance. It's basically, if you want more details on this, you can actually go back to my channel and check out videos on VPLS, because service instance, bridge domains, virtual forwarding instance, these are very much used over there, right? So this is nothing but, for now, think of service instance as as like one sub interface, right? You're creating a sub interface out of it, right? So service instance 10, right? And remember from my L2 configuration, what is the VLAN which we have used? The VLAN.1q is 10. Okay, so we have used 10 for sales, right? That's why we are using the same VLAN here, bridge domain 10, right? Similarly, we'll have to do the same thing for, let's go back again, you have to exit this. You have to do service instance again, right? Service instance 20, Ethernet, and encapsulation dot 1q, right? 10, and sorry, my bad, it's 20, right? We have already used 10. Cool. And the bridge domain is going to be 20 here. You're getting the drift now, right? And the third guy is going to be my obviously the 30. So let me quickly show you what we have done here. Show run interface gig 2, right? This is what we have. So you get the point, right? Why are we using VLAN 10 or .1q 10, .1q 20 and 30? Because if you see from my diagram here, those are the VLANs which are coming from the trunk ports, right? So we are using the same thing on the CSR side as well. All right, so now what we're going to do is quickly take all these 3 guys, right, and we can do the same thing on the rest of the edge switches as well. It's going to be the same, and on the third gun as well. All right, done. Maybe I would need to do a no shut here, right? There you go, the no shut is done, and a no shut here as well, and probably here too, which I probably forgot. gig to no shard. All right, so that's done. So we have done with the creating service instance, but you see here we have created service instance and we have attached a bridge domain, but we have to explicitly define a bridge domain interface as well, right? So we have to now define those interfaces. So let's go and do those. How do you define that? Let me clear the screen again, right? This is again, this is all roundabout way we are doing this because we can't really create sub interfaces in your CSR100v, right? Or if you guys have a different way of doing it and if you found it, please drop it in the comments so that it will be a good learning for me as well, right? Cool. So let's do the bridge domain now. So we have created those 3 bridge domains. We have to just go and configure them. So we're going to say interface bridge domain. Sorry, let's go back again. So interface bridge, I think it's called BDI. Yeah, bridge domain interface 10, right? Remember the first one. And on this one, now this bridge domain, right? We want this bridge domain for what? What kind of traffic will be coming on this bridge domain? It's a sales traffic. So we have to put this bridge domain or this interface in the VRF sales. So let's do that. It's going. Wait. Let me just double check. This 10 is sales, or okay. So I might have kind of. Let me just correct this. Right. I think in my topology, what I intend to do is I want 10 to be IT, right, and 20 to be sales. So let's go with that, right? That's going to be easier. Anyway, so what we have to do here is change this to VRF forwarding IT. That's it, right? Let's put an IP address here, right? And the IP address is from the same subnet. What is the subnet? Remember from our diagram, 172.16.10.0. So 16.10.0 instead of, this is going to be, this is what we are creating right now, right? In your traditional network, what would this map to? It is nothing but the SVI, right? Let me probably draw the diagram here. Let me just get rid of this for a minute. All right. So let me do this. Okay. So just to clear the confusion, if there is any, let me again. Okay. So we have the CSR100v. We have the IOL device here, right? IOL switch, and you have the clients hanging out from here. This is trunk, and this is we have converted this into a bridge domain interface, right? We have BDI 10, we have BDI 20, we have BDI 30. This is nothing but corresponds to in your traditional Cat 9K, right? Your clients will be hanging out from here directly. You would not need to have these two devices, right? You can directly make this guy as a switch port, and instead of this BDI, right, you would basically have SVIs, right? And the SVIs will be the default gateways, right? So for your sales, for your IT, right, you will basically have SVIs, which will be the default gateway. So when the clients come and connect, right, in this particular VLAN, right, the sales VLAN, right, they'll have corresponding SVI as the default gateway, right? So now we are basically, since we really can't emulate this Cat 9K assets, that's why we are doing it this way. And the SVI, since we can't create SVIs on CSR1000v, we are basically going to use this bridge domain interface, right, as the SVIs or as the default gateways. So that's what we are going to go and configure, right? So the SVI for this guy, right, or actually in campus fabric terms, they call this as the anycast gateway, right? And this is 172.16.10.1, right? And for the second guy, it is going to be 172.16.20.1. Right? That's what we are going to do now, right? So let's go back here. IP address 172.16.10.1, 255.255.0, right? Makes sense? And don't forget the encapsulation, right? The encapsulation is .1Q10, right, for this particular bridge domain. And what else? That's done. Is there anything else needed? Okay, the other interesting thing is, let me also talk about, since we are already on the topic, let's talk a little bit about this anycast gateway. This anycast gateway is actually very interesting, right? It does a lot of cool things for us. So let me just get rid of this, right? The idea behind this anycast gateway is, in your enterprise network, right, you can have you'll have different edge switches, right? And you might have one client who is connected here for now, but he walks up to and then probably later goes and connects to this switch, right? Now the whole idea in campus fabric is you want to create this anycast gateway, and the same gateway is going to reside on all the 3 access switches, right? Which means the 172.16.10.1 is going to be there on this guy, and this guy as well, right? And also, to make it even more fun, what they do is they go and encode the MAC address as well, right? Let's say the MAC address is A over here, right? They'll put the same MAC address here as well for that particular gateway, right? The reason is when this guy walks up to a different location, like behind this particular switch, right, he can still connect to the same gateway which has the same MAC address, right? He doesn't have to do any extra work, right? So it's the mobility is going to be very seamless, right? So that's the reason why people use anycast gateway, and that's exactly what we are going to do as well. So we have created the anycast gateway, but now let me go and put a MAC address as well, right? So I think I already have a MAC address. I'm going to use that here. So there you go. I'm putting a MAC address as well over here. Let's do a no shut. Sweet. There are some Lisp stuff and configurations which we'll probably do that later, but for now I think that looks good, right? So what I'm going to do is, let me pause the video and quickly do the configuration of the rest of the bridge domain interfaces, and I'll come back, because otherwise if I'm manually typing it here, the video is going to be too long. Alright, so we are done with that. Just to quickly show you, you can see all the 3 bridge domain interfaces are up, right? You can see here the same 3 are up here as well on my H2 and H3 as well, right? And just to show you the configurations again, show run interface BDI 10 is this, 20 is this, and 30 is this. They are just created so that the traffic, so BDI 10 will get the traffic coming from the IT clients, BD 20 will get the traffic coming from sales, and 30 will get the traffic coming from the AP VLAN, the infrastructure VLAN, which is there in the underlay, which is not part of, this is not part of any VRF, right? So these 2 are part of the VRFs, whereas this is in the global routing table only, the 192.168 subnet, right? And this is the default gateway as such. So all the 3 are configured. So that was about configuring that. Okay.